Humans have always been fascinated gazing at the night sky. On any clear night, the moon and the bright planets and stars are the first things to catch your eye. But those are just the beginnings of what you can see if you know where to look. The best astronomical sights are the deep sky objects, star clusters and nebulae associated with our Milky Way galaxy, and the fuzzy island universes that are other galaxies, located many millions of light years away, but still within reach of amateur telescopes. Deep sky objects are celestial objects that exist outside our solar system. Three major types of deep sky objects are nebulae, star clusters, and galaxies. The word nebula is Latin and means cloud. A nebula is a cloud of gas and dust in space. Three types of nebulae exist: bright, dark, and planetary. Bright or diffuse nebulae are frequently places of star formation. When stars begin to form, the region becomes so hot that the star's radiation excites the gas of a nebula, causing it to shine. This type of bright nebula is known as an emission nebula. The process by which the gas, hydrogen, is excited is called ionization. Neutral, non-ionized hydrogen is designated H1. Ionized hydrogen is represented as H2. For this reason, emission nebulae often are referred to as H2 regions. If the stars are not hot enough to cause ionization of the surrounding gas, the starlight is reflected by the dust, and can be seen as the second type of nebula, a reflection nebula. These nebulae look blue for the same reason our daytime sky appears blue: the light is being scattered throughout the nebula. A lot of nebulae have both emission and reflection components, because some of the gas may be too far from the stars to be ionized by their radiation. The first bright nebula discovered was the Orion Nebula, M42, in 1612. The first reflection nebula discovered was M78, also in Orion, in 1780. Other well-known diffuse nebulae are M8, M16, M17, M20, and M43. M16 is actually a double object, a star cluster, NGC 6611, and a famous nebula known as the Eagle Nebula, IC 4703. M45, the Pleiades, also contains a reflection nebula. Dark nebulae are clouds of dust and cold gas that can be seen because they obscure light from stars or bright nebulae behind them. The shapes of dark nebulae are among the strangest in the sky. Some dark nebulae, such as the Horsehead Nebula in Orion, are small and difficult to see even with large telescopes. Others, such as the Coalsack and Crux, are large and easy to see with the naked eye. The darkness of these objects is due to dust grains within the clouds and to the presence of extremely cold hydrogen molecules. The largest of the dark nebulae, called molecular clouds, are huge areas of star formation. The clouds must be cold, or the radiation will heat up the individual atoms and prevent gravity from collecting them together. This would keep the gas from condensing into stars. The first catalog of dark nebulae was prepared by American astronomer Edward Emerson Bernard. A planetary nebula is the most common end product of stellar evolution. Stars about as massive as the Sun eject mass when they become red giants near the end of their lives. After about 10,000 years, the inner core of the star collapses and the star pulsates, ejecting much of its outer envelope. This leaves a small star called a white dwarf. The ejected envelope becomes a spherical shell of cool, thin matter expanding into space at 5 to 25 miles per second, a planetary nebula. The star, now called the central star of the nebula, is extremely hot, reaching temperatures of 200,000 Kelvin. It also emits a large amount of ultraviolet radiation. This radiation ionizes the gas of the expanding planetary nebula and causes it to glow. Planetary nebulae have short lives, at least visually. As the shell expands, the white dwarf's energy can excite the gas, but only out to a certain distance. So after 10,000 to 50,000 years, the planetary nebula stops glowing. It's still expanding, but we can no longer see it. Most astronomers agree that a planetary nebula is the fate of our Sun in approximately 5 billion years. On July 12, 1764, French comet hunter Charles Messier discovered the first planetary nebula and made it number 27 on his famous list of objects that are not comets. M27 also is known as the Dumbbell Nebula. It took 15 years before the next planetary nebula was discovered. The object was the now famous Ring Nebula, M57, and it was found in January 1779 by another French astronomer, Antoine Darquier, who compared it to a fading planet. The German-born English astronomer William Herschel christened these objects planetary nebulae because they resembled in shape and color Uranus, the planet he had discovered only a few years before. There are roughly 1,000 known planetary nebulae in our neighborhood of the galaxy. A typical planetary nebula is less than 1 light-year across. A star cluster is a group of stars loosely held together by gravity. There are 3 types of star clusters: associations, open clusters, and globular clusters. Associations contain dozens of stars and resemble open clusters, except that they are poorer in stars. Located within the disk of the Milky Way galaxy, open clusters also are known as galactic clusters. The Beehive, M44, the Pleiades, M45, and the Hyades clusters have numerous historical references. In the 2nd century, Ptolemy mentioned Melet 111 in Coma Berenices and M7 in Scorpius. Not until Galileo trained his telescope on the Beehive, however, was it discovered that these objects are made of individual stars. Sparse open clusters contain less than 100 stars, while rich ones may have thousands. Open clusters form from nebulae. All open clusters are relatively young objects, generally no more than a few 100 million years old. We know the open clusters we observe are young because, given enough time, the stars in an open cluster disperse due to gravitational interaction within the cluster. If we were able to follow a single open cluster from its formation, we would see the cluster disperse stars throughout its entire galactic journey. Approximately 1,700 open clusters are known. The other main cluster type is a globular cluster. These objects are spherical in shape, and the greatest concentration of stars lies toward their centers. Globular clusters have many more stars than open clusters, ranging from about 10,000 stars to more than 1 million stars. Globular clusters are old. Most are in excess of 10 billion years old. What really sets globulars apart, however, isn't their age, but their location. Open clusters lie within the spiral arms of our Milky Way galaxy. Globular clusters surround the Milky Way in a spherical distribution. This structure is often called the halo. Studying the distribution of globular clusters around the Scorpius-Sagittarius area correctly led Harlow Shapley to conclude that the center of our galaxy must lie in that direction. M22, a beautiful object in Sagittarius, was the first globular cluster to be discovered in 1665. 12 years later, the Great Southern Globular Omega Centauri was observed by Edmund Halley. Today, about 200 globular clusters are known to surround our galaxy. Globulars have been observed around many other galaxies as well. As an example, the giant elliptical galaxy M87 in Virgo contains more than 1,000 globular clusters. You might wonder how objects composed of up to 1 trillion or more individual stars could be so difficult to observe. Of course, the answer is distance. Galaxies are so far away that, except for a small number, they all appear small and faint. Even advanced observers regard observing faint galaxies as a challenge. Today, we are indebted to the great American astronomer Edwin Hubble for developing a simple classification scheme for galaxies. Hubble first mentioned this in a paper he wrote in 1922. 4 years later, he expanded it and added some illustrations. Finally, in 1936, Hubble provided a better explanation of the classification scheme in his book The Realm of the Nebulae. And it was in this book that the famous tuning fork diagram first appeared. Hubble's scheme describes several different main types of galaxies: ellipticals, spirals, and barred spirals. The 4th class contains irregular galaxies, essentially every galaxy not on the fork. After stars form, they arrange themselves into clusters. So do galaxies. Clusters of galaxies may be made up of a handful of galaxies or as many as 1,000. As with star clusters, clusters of galaxies are held together by mutual gravitational attraction. Please note that a galactic cluster and a cluster of galaxies are totally different. The first is a group of stars, also known as an open cluster. The second is a group of galaxies. The most famous cluster of galaxies is the one that contains our two other well-known and well-observed clusters of galaxies are the Virgo cluster and the Fornax cluster. The Virgo cluster lies nearly 50 million light-years from Earth and is a bright cluster. A number of Messier objects are members of it, including M49, M60, M84, M85, M86, M87, M88, M89, M90, M98, M99, and M100. In addition, more than 100 NGC galaxies belong to the Virgo cluster. Many observers think the Fornax cluster is the finest for amateur astronomers to observe. 18 galaxies make up the cluster. The brightest is NGC 1316 at visual magnitude 8.8. NGC 1399, magnitude 9.8, is the next easiest to see. NGC 1365 is third at magnitude 9.5. This galaxy is a barred spiral seen face-on, with open spiral arms. The largest separate structures in the universe, and some would say the structures that define the shape of our universe, are superclusters of galaxies. The local group, which contains the Milky Way, belongs to a supercluster of galaxies called the local supercluster. The local group is at one end, and the Virgo cluster is near its center. The major axis of the local supercluster stretches 125 to 150 million light-years. Other nearby superclusters of galaxies include the Hydra Centaurus supercluster, which lies at a distance of about 150 million light-years, and the Perseus supercluster, which is roughly 220 million light-years away. Telescopes help us see stars and galaxies that are very far away. It takes a long time for the light from faraway galaxies to reach us. So, when we look into the sky with a telescope, we are seeing what those stars and galaxies look like a very long time ago. So whenever you look at the sky, you are looking back in time. Hey, I am Miss Keen. Thank you for watching. Don't forget to like, comment, share and subscribe to my channel. And for latest update, hit the bell icon. Until then, keep exploring.